Welcome to One Chemistry. In this video, we are going to see what is hemoglobin, basics behind it, and 17 fully solved examples. We are going to see all important concepts. Stay tuned. For your quick reference, I given all the facts about hemoglobin, including metal, ligand, proximal and distal histidine, hydrogen bond, cooperativity, poisoning, Bohr effect, Berude's mechanism, concentration of oxygen versus affinity, color of hemoglobin, what is methemoglobin, what is T state, that is tensed state, R state, that is relaxed state, magnetism, number of paired and unpaired electron, metal oxidation. So this will be the quick reference and summary of all the facts in this video. Make use of it. First, let us see what is hemoglobin. Hemoglobin is a carrier. It carries oxygen molecule, transport the oxygen inside the human body, take in lungs, deliver to the required place. So, what is the function of hemoglobin? Transportation of oxygen in human body. Hemoglobin basically take oxygen and release in the required place. This makes hemoglobin unique because binding is reverse. It catch the oxygen and release the oxygen. So attachment is weak. So it play reversible reaction. Hemoglobin known as Hb symbol. So we will see Hb as hemoglobin. And important fact is heme contain 4 iron metal, so it can take 4 oxygen. First oxygen intake is slow, then kinetics of intake is fast. Fourth hydrogen will be the faster one. So the fact you have to know here is hemoglobin oxygen binding is reversible. It can take up to 4 oxygen molecules. Then we will see structure. Structure of hemoglobin is simple. It is a tetramer, meaning 4 iron molecule covered with protein chain. The protein chain hold 4 heme units together. It is basically a coordination chemistry. Iron is the central metal. Heme is the ligand. It makes coordination compound. The structure contains 4 such units, that is called hemoglobin. So the fact you have to know here is iron is the metal, 4 iron is inside, 4 units are inside. Then we will see more about the structure. Iron has 2 plus oxidation state. The central metal of heme unit is iron, that is metal ligand interaction. Metal is iron, ligand is porphyrin ring. The oxidation state of iron is 2 plus. The coordination number is 5, 4 from porphyrin, 1 is from histidine. The histidine is called proximal histidine. Then sixth position is free for oxygen intake. So totally coordination number is 6. So you should learn not only biomolecular nature, you should learn chemical bonding also. Then oxygen nature also important. Why? Because how oxygen is binding? Oxygen is bind as O2, not as superoxide, that is O2 minus, not as peroxide, that is O2 2 minus. Then histidine, there are two histidine, proximal and distal histidine. Proximal is already in the structure. Distal histidine comes when oxygen binds. The important fact is hydrogen bonding help the connection between distal histidine and oxygen. Then Bohr effect, very important concept. It explains pH control of oxygen binding. Since oxygen binding is reversible, by varying the pH, you can control oxygen intake, oxygen release. In lungs, CO2 level will be low, that is less acidic, pH will be high, oxygen pickup happen. On the contrary, muscle CO2 levels are high, acidic, pH will be low, oxygen will be released. So pH can control oxygen pickup, oxygen drop. So if you increase the pH, oxygen affinity is high. If you decrease the pH, oxygen affinity is low. So higher the pH, more oxygen affinity. Then Bohr effect, sometimes explained as curve. X-axis is pressure. Why pressure mean gases are explained in pressure, not by concentration, because difficult to weigh the gases. Pressure will be the correct measurement. Y-axis will be percentage of hemoglobin binding. So you can clearly see low pH, there is a bad binding. You can clearly see low pH binding is low, high pH binding is high. So without CO2 there will be a good binding. With CO2 there will be a oxygen release. So you should know the curve because sometimes they ask you to label the curves. Then same thing you compare two biomolecule, that is hemoglobin and myoglobin, both control the oxygen. Hemoglobin has the sigmoidal curve, myoglobin has the parabolic curve. The sigmoidal nature come from cooperativity. Fourth oxygen binding will be high, that makes the curve sigmoidal. Then cooperativity, basically it's a conformational shift, increase the oxygen affinity, meaning binding of fourth oxygen will be better than first oxygen. What really happen is packing of oxygen in the system. What really happen is kinetics is increased for every oxygen binding. Here I given K1 as a constant. If you look at it, K4 will be very high when compared to K1. So every binding increases the affinity. That will be explained by T and R state. We will see shortly. So the fact you have to know here is cooperativity means kinetics of fourth oxygen binding will be higher due to the conformational change. The very same cooperativity dictate the sigmoidal curve in oxygen binding. Then T state or R state, technically tensed and relaxed state. In normal hemoglobin, the iron atom will be out of the plane. Because of its bigger size, it will be out of plane. The molecule will be non-planar. It has low affinity of oxygen. When oxygen binds, iron packed into the system, it fit perfectly into the porphyrin molecule, became smaller in size. So oxygen affinity is higher. That promotes cooperativity. So T state and R state is important, particularly oxygen affinity. Then the magnetic property. Hemoglobin takes the oxygen become HbO2. During the transition, there is no change in the oxidation state. Only change in the size happen. Smaller the size create the high splitting that leads to low spin. So oxyhemoglobin is low spin and diamagnetic. That will be easy to memorize. The trick is old. O stands for oxy, L stands for low spin, D stands for diamagnetic. The reason is size create the splitting that leads to low spin. We will see magnetic property much more detailedly. Deoxyhemoglobin and methemoglobin, three category that involve oxygen hemoglobin interaction. When hemoglobin takes the oxygen, it becomes low spin, no unpair of electron, become diamagnetic. If it is not with oxygen, oxidation state is same Fe2 plus, spin is high spin, that creates 4 unpaired electron because 6 electron you have to draw, one will be paired, so 4 unpaired electron that create paramagnetic nature. Then met hemoglobin, it is oxidized hemoglobin. The oxidation state is 3 plus D5 octahedral high spin, which creates 5 unpaired electron become paramagnetic. So oxy diamagnetic, deoxy paramagnetic, met hemoglobin paramagnetic. Then very important thing, oxidation state. Normally 4 biomolecules on hemoglobin known oxyhemoglobin, that is Fe2 plus, deoxyhemoglobin, that is also Fe2 plus, methemoglobin, that is oxidized hemoglobin, Fe3 plus, hematine, that is also Fe3 plus. What you should know here is oxygen binding of hemoglobin don't change ion oxidation state. Then why hemoglobin is red color? It is a kind of controversial topic. Many counter arguments are known, but popular answer will be interligand pi-pi transition create the red color. Oxyhemoglobin has bright red color. Deoxyhemoglobin has purple color. The ligand is porphyrin. Metal is obviously iron metal. The charge transfer between the ligand create the red color. So you should know counter fact. It is not due to DD transition. It is due to pi to pi star transition. Then we are going into the very important session, solved examples. We are going to see as many examples as possible because problems are best way to learn. It will give different perspective and complete understanding. The first question is red color of hemoglobin is due to DD transition, metal to ligand transfer, interligand pi to pi star transfer, ligand to metal charge transfer transition. Among the four, you should find which is responsible for red color of hemoglobin. We already seen that the color of hemoglobin is due to interligand pi to pi star transition. Deoxyhemoglobin has bright red color. Oxyhemoglobin has dark red color. Since there is no oxidation state change, you can clearly see it is not due to DD transition, only due to ligand charge transfer. Then the next question, oxidation state of iron in methemoglobin is A3, B2, C0, C4. Oxyhemoglobin, methemoglobin has Fe3 plus charge. It is oxidized hemoglobin. That's why question is asked. The relevant facts are oxyhemoglobin has Fe2 plus oxidation state. Deoxyhemoglobin has Fe2 plus oxidation state. So metglobin ion charge is plus 3. Then the next question, the iron N porphyrin bond distance in deoxy, oxy, hemoglobin respectively are A 2.1 and 2.0 Armstrong, B 2.0, 2.0 angstrom, C 2.2 and 2.3 angstrom, D 2.3, 2.5 angstrom. The answer is A. It is a tricky question because iron size in deoxyhemoglobin is higher than oxyhemoglobin. The question is not about the number, whether you understand the problem or not. So only possibility is A because deoxy is higher than oxy. That could be our answer. The reason is high charge density of Fe2 plus because of smaller size. It pull iron and nitrogen, make the iron nitrogen bond smaller and stronger. So answer is 2.1 and 2.0 angstrom. Then the next question, match the following. Column A contain hemoglobin, cytochrome B, vitamin B12, hemocyanin. The column B contain electron carrier and iron, electron carrier and copper, electron transport and copper, group transfer reaction and cobalt, oxygen storage and cobalt, oxygen transport and iron. So you should match biomolecules and function. Our focus is hemoglobin. Hemoglobin is oxygen transport and iron containing molecule. Why this question is given mean you should study relevant biomolecule, then only you can answer composite question. Here cytochrome B role is electron carrier and iron. Vitamin B12 is group transfer reaction and cobalt. Hemocyanin is oxygen transport and copper. So study similar molecules, then only you can solve the problems without any doubt. Then the next question. In the absence of bound globin chain, heme group to oxygen give the iron oxygen species. Four possibilities: A. Fe3 plus with oxygen, B. Fe with superoxide, C. Fe3 plus with superoxide, D. Fe4 with double bonded oxygen. So you should find which biomolecule is formed. The globin chain protects the oxidation process. If the globin chain is not there, iron become like normal iron. It will oxidize to 3 plus. So answer will be A, 3 plus and 3 plus with oxygen. B is not possible because superoxide. C is same superoxide with Fe3 plus. So that is also not possible. D is 4. Iron 4 plus oxidation state is rare. So only possibility is A, Fe3 plus, O Fe3 plus. Then the next example, the resonance Raman stretching frequencies in centimeter inverse of bound oxygen species in hemoglobin respectively are 850 and 1100, 750 and 850, 850 and 850, 1100 and 850. The answer lies in the basics binding of hemoglobin and hemerythrin. Hemoglobin oxygen bind as a double bond. Hemerythrin oxygen bind as a single bond. So in the answers, hemoglobin should have higher values than hemerythrin. Only the answer A has the possibility because energy of oxygen bond in hemoglobin is higher than hemerythrin. So A is our answer, 850 and 1100. Then oxyhemoglobin has iron in Fe2 plus state, Fe3 plus state, both Fe2 plus and Fe3 plus. D. Iron as the metal, that is Fe0. The question is about oxidation state during the binding, whether oxidation state changes or not. As we know already, both oxyhemoglobin and deoxyhemoglobin ion will be on same oxidation state Fe2 plus. Only size and spin are changed, not the charge. So answer A is correct. Fe2 plus state. Then in vitro reaction of excess O2 with free heme B in aqueous medium. The end product is hematine, oxygen Fe3 protoporphyrin complex, hematine BO2, oxoferryl protoporphyrin cation radical. Among the four, you should find which will be the product. Hematine is our answer. That is popular one because this is the attempt to create oxygen binding outside the body, that is called in vitro reaction. Outside the body it becomes Fe3 because of absence of globin chain, it become oxidized. So hematine is our answer. Then the next question, in oxyhemoglobin, ion center is best described as high spin Fe3, high spin Fe2, low spin Fe3, low spin Fe2. So you should find number of unpaired electron and oxidation state. As we discussed already, oxidation state don't change, always Fe2 plus. So we can eliminate A and C. So B and D could be our answer. The fact can be memorized easily from the word volt, oxy, low spin, diamagnetic. So our answer is low spin and Fe2 plus. That is D is our answer. The concept you have to learn here is you memorize both in terms of hemoglobin, deoxyhemoglobin and oxyhemoglobin. Then the next question, function of hemoglobin is store oxygen in muscle unit, catalyze biochemical process, transport oxygen from lungs to various tissues through blood, help muscular movement. The answer is simple and straightforward. While inhaling, oxygen is taken by hemoglobin, delivered in the muscles. Hemoglobin transport oxygen. So C is our answer. Transport oxygen from lungs to various tissues through blood. Hemoglobin is an iron containing protein involved in binding and transport of oxygen in the blood. The oxygen binding affinity of hemoglobin depends on pressure and pH. The choices are increases with increase in pressure and pH, decreases with increase in pressure and pH, increases with increase in pressure and decreases with increase in pH, decreases with increase in pressure and independent of pH. So you should find dependence of pressure and pH in oxygen binding. The question is about Bohr effect. Bohr effect means more pH, more oxygen binding, more pressure, more oxygen binding. Here oxygen gas expressed in pressure because of its gaseous nature. So only A is our answer because increases with increase in pressure and pH. The concept you have to learn here is Bohr effect is a switch which control oxygen binding by its pH tuning. Then the next example, the molecules involved in CO poisoning and CN poisoning are deoxyhemoglobin, oxidase, cytochrome C oxidase, deoxyhemoglobin and reduced cytochrome C oxidase, oxyhemoglobin and oxidase cytochrome C oxidase, deoxyhemoglobin and reduced cytochrome deoxidase. So you should find which involve poisoning. The question is about basics. The competition in hemoglobin binding of oxygen with CO, because CO bind better than oxygen, create the poisoning, because once occupied by CO, it cannot take further oxygen. Suffocation leads to the death. So CO poisoning happen in deoxyhemoglobin, and CN poisoning happen with oxidized cytochrome C oxidase. Then the next question, which of the following gases reacts with hemoglobin of blood to produce toxic effect? A. CO2, B. NO2, C. SO2, D. CO. We already discussed CO is a competitor for oxygen because it binds better than oxygen. Linear binding leads to the irreversible binding of CO. Once bind with hemoglobin, don't allow the oxygen intake, create suffocation, further death. So CO is creating poisoning in terms of hemoglobin. Then next question, cooperative binding of hemoglobin is due to decrease in size of ion followed by changes in protein conformation. A decrease in size of ion followed by changes in protein conformation. A decrease in size of ion not accompanied by changes in protein conformation. A decrease in size of ion not accompanied by changes in protein conformation. Here you should find cooperative binding means what? The answer is simple. Once oxygen binds, size of ion will be less. Change the protein conformation. Create R state. Promote the cooperativity, that is conformational shift. Create increase the oxygen affinity. That's why K1 is lesser than K2, then K3, then K4. K4 bind faster because of cooperativity. So our answer is A, decrease in size of ion followed by changes in protein conformation. Then the next question, under physiological condition, oxygen binding to deoxyhemoglobin and deoxymyoglobin, the binding curve and its pH dependence respectively are, the choices are A. Sigmoidal and pH dependent, hyperbolic and pH independent, B. Hyperbolic and pH independent, sigmoidal and pH dependent, C. Sigmoidal and pH independent, hyperbolic and pH dependent, D. Hyperbolic and pH dependent, sigmoidal and pH independent. So you have to distinguish hemoglobin and myoglobin. We seen in the Bohr effect that hemoglobin has sigmoidal effect due to the cooperative nature. pH dependency improves due to cooperativity. Myoglobin don't have any cooperative effect, so the curve will be normal, hyperbolic and pH independent. So our answer will be A, sigmoidal, pH dependent, hyperbolic and pH independent. Then the next question, the oxidation state of methemoglobin is A. Fe2 plus, B. Fe3 plus, C. Fe4 plus, D. Fe0. The answer is simple. Once you know methemoglobin, in normal hemoglobin, oxidation state don't change. In methemoglobin, oxidation state changes to Fe2 plus 2 plus 3. The disease is called methemoglobinemia. So our answer is B, Fe3 plus in methemoglobin. Then final example, Perut's mechanism related to oxygen binding in hemoglobin, cooperativity in hemoglobin, Bohr effect in hemoglobin, magnetism in hemoglobin. The answer is cooperativity in hemoglobin, that is technically called Perut's mechanism, which explains cooperative binding is interplay of iron atoms movement within a heme group, proximal histidine residue, and salt bridges between protein subunits. So our answer is Perut's mechanism related to cooperativity in hemoglobin.